This video is sponsored by DevMountain. If you're interested in learning web development, iOS, or UX design, DevMountain is a 12-week design and development bootcamp intended to get you a full-time position in the industry. To learn more, visit devmountain.com or click the link in the description below. Hey, what's going on, guys? So we're going to do something a bit different today. I get a lot of requests for machine learning and AI tutorials, which is something that's pretty new to me. Frankly, it's pretty new to most developers. So today I want to look at facial recognition using the Python face recognition library. So relative to most stuff like this library is actually pretty easy to use, and it's pretty powerful when it comes to learning and matching faces. So we're going to go through a lot of what you'll find in the docs, but hopefully I can make a little more sense through some examples. The library works with packages like Pillow, which is an imaging library, NumPy, which allows us to do things like perform calculations over entire arrays, analyze data more efficiently, so it's used heavily in data science. So we're going to jump right in here. Now you can do stuff with your webcam and video as well, but we'll be working strictly with images, matching faces, and so on. So we're going to go ahead and install this. So you can see here we can install it with pip. Now I'm going to open up Visual Studio Code. So I'm going to use my integrated terminal here. We're going to be working within the terminal for a little while before we start creating files. And we need to, first of all, set up a virtual environment. I mean, you don't have to do this, but it's preferred. So you can install with pipenv. Okay, I already have it installed, so I'm not going to run it. Once you do that, you can do pipenv shell, which will start your virtual environment. All right, and then we're going to do pipenv install, and we want to install face underscore recognition. All right, so once that's done, we should be able to use it. So I have over here an image folder with a folder called known and a folder called unknown. And inside known, I have 4 well-known people. I have Barack Obama, Bill Gates, Donald Trump, and Steve Jobs. So very diverse. And in unknown, I have a bunch of pictures. Some of them are of these 4 people. Some of them are not. You can see we also have Mark Wahlberg in here. We have Michael Jordan, Keanu Reeves, and then I also have a Bill Gates lookalike, which is right here. So a guy that looks like Bill Gates but isn't actually him. All right, so what I want to do is run a match on the known and unknown folders and see which of these are actually pictures of these 4 people. So we can do that really easily in the command line by just doing face underscore recognition. And then we want to first put in the known folder, so ./image/known, and then ./image/unknown. All right, so let's go ahead and run that, see what we get. Okay, so it's going to go through each image, and it's going to show us the match. Okay, so you can see right here, this Obama image, it comes up with Barack Obama because it's matching the file name of the known image. So we got Trump, we got Obama, Bill Gates. This is an unknown person. This is actually Michael Jordan, and he's not in the known folder, so he's unknown. Keanu Reeves is unknown. We have Steve Jobs, Jordan again, unknown. Steve Jobs, Bill Gates. So you see, it does a pretty good job. Now, one thing you might notice is the Gates lookalike actually comes up as Bill Gates. Okay, now I want to show you how we can fix this. So we can actually show something called the distance of each match. So basically how much of a match it is. And we can do that by running that same command with a flag of --show-distance and set that to true. So now along with the match, it's going to give us a number, a decimal here. And you can see that I just want to show you most of these are like 0.3, 0.4. The real Bill Gates, you can see 0.37. Where's another one with Bill Gates? Right here, 0.36. But notice that the Gates lookalike, which is right here, is 0.57, so higher than the rest. So what we can do is we can change the tolerance. So basically we can target the faces even better by adjusting it to something lower than this 0.57. All right, so we'll clear this out, and we're going to run this command again, but we're going to now add the flag tolerance and we're going to set it to 0.50. So anything under 0.57 should make it so that the Bill Gates lookalike is unknown. So let's go ahead and run that. All right, so right here, Gates lookalike, and you can see that it's an unknown person. So he's not coming up as Bill Gates anymore, but the other ones are. So we have right here Bill Gates, and where's the other one? Right here. Okay, so you can see that the real Bill Gates is showing up, but the lookalike isn't, because the distance was 0.57, and we set the tolerance to 0.50. All right, so you might want to adjust that tolerance if people that aren't that actual person are coming up. All right, so hopefully that makes sense. Now, if we want to get just the names of the people in the image, we can do that as well. So I'll clear this out, and we can do face. Actually, let me just go back to this command here, but we want to add on to the end here a pipe character, and then do cut -D, and we just want to put a comma within quotes here, and then -F2. So if we run that, it's going to just give us the names of the people in the images. Okay, so now you can see we just have the names, and it just uses unknown person as if the person doesn't get found. So let's actually take one of these images. Let's take a picture of Michael Jordan, and let's move it into the known, and let's rename this to Michael Jordan. And now if we run this again, we should get the match for Jordan. Okay, so now you can see we have Michael Jordan right here, right here. So now we're getting those matches as well. And all these commands are in the documentation, so I'm not going to include them in the description or anything. It's all on the GitHub page. But yeah, so that's how we can match images. Now, if we want this to go a little faster, if you have a powerful computer, you can actually adjust the CPUs. So if we go to our original command right here, and we just add on the flag --CPUs, and I'm going to say CPUs 8. So it still takes a second to get started, but look how fast it goes. Okay, it's going to go much faster, and you probably want to do that if you have like a shitload of images that you're going through. All right, but yeah, so that's how we can use the command line to find matches. Now I want to start to get into writing Python files that can work with this library. So I'm going to clear that up, and let's make this smaller here, and close up these images. And I'm going to create a new file called findfaces.py. So what I want to do here is look at an image of people. So you can see I have a folder called groups, and I have team 1 and team 2, and I want to be able to recognize faces, or even the locations of the faces in the image. Okay, and also be able to count the number of faces. So we're going to go ahead and import the face recognition library, and we're going to set a variable of image, set that to face_recognition, and there's a method called load image file, and this actually loads the image as a numpy array. So in here we want to put the location, which is image/group/team1.jpg. Okay, so now we have that image. Now we need to get the locations of the faces. So let's do face locations. We'll set a variable, and we'll set that to face recognition.face_locations, and we just simply pass in the image. All right, so once we do that, we can get an array of coordinates of each face, or for each face. And we can print that out if we want. So let's print out face_locations and see what that gives us. So I'm going to go ahead and clear this up down here, and let's run Python and findfaces.py. So you can see that now we get this array which has these coordinates inside of it for each image, and team 1 has 4 people in it, so that we have 4 values, which are the coordinates top, right, bottom, left. Okay. Now, if you just wanted to find out the number of people within an image, that's really easy. We could just print. I'm going to use an F string here so I can use a variable inside or an expression. So let's say there are, and then we'll open up some curly braces, and I'm going to use the len method, which will just count the number of array items, and then face locations, because that's an array, and we'll say faces, or even just people, if you want to count the number of people in this image. All right, we'll go ahead and just comment this out. So let's run that, and we get there are 4 people in this image. If we change this to team 2, which has a lot more people, and we run it, we get there are 11 people in this image. Okay, so just this little bit of code, you can examine an image and find out how many people are in it. All right, so that's the first thing I want to do. Now I'm going to create another file in the root here, and let's call this facematch.py. So basically, I want to do what we were doing in the command line, where we were comparing images and seeing if that person is in that image. So let's again import face recognition, and I'm going to have an image. Let's do Bill Gates. So we'll say image of Bill, and set that to face recognition dot load image file, and I'm going to load dot slash img slash known slash Bill Gates dot jpeg. Okay, now we need to get something called a face encoding of Bill Gates, and this will get the facial features that can be compared to other images. So let's create a variable called Bill underscore face underscore encoding, and we're going to set that to face recognition, and there's a method called face encodings. So we're going to use that. We're going to pass in the image of Bill. Now this will give us an array. We just want the first item. All right. Now we want an image to compare it to. So we'll say, let's call this unknown image. Actually, I'm going to just copy these 2 lines, and we're going to change this to unknown image. And let's use, we'll say image unknown. And let's actually grab one that is an image of Bill. So we have, let's see, easy name, bill-gates-4.jpg. So that's what we'll compare it to. .jpg. All right, and then here we'll say unknown. Let's do unknown encoding. Or unknown face encoding, and set that to face recognition, face encodings, and then we want to pass in the unknown image and the 0 index. So now we have our 2 images that we want to compare, right? So let's do compare faces. So there's actually a method called compare faces, and I'm going to put this inside of a variable called results so we can test it after. So let's say face recognition dot compare faces. It's going to take in brackets. You can actually put more than one in here, but we're going to do Bill face encoding, and we're going to match it to unknown face encoding. All right, so this should give us a true or false value. So we're going to check results. So we'll say if results 0, then let's print this is Bill Gates, else then we'll print this is not Bill Gates. All right, so let's save that. Let's try it out. So I'm going to go down here. I'm going to run Python, and this is what, facematch.py. And we get this is Bill Gates. So let's change this unknown image to one that is not him. So we'll do, let's do d-trump.jpg, and we'll run that. and we get this is not Bill Gates. All right, so we're basically doing the same kind of thing we were doing in the command line, and you can get much more in depth with this. But I want to move on. I want to show you how we can actually pull faces out of an image, and we can even save them. We can take each of these faces and save them as a separate image, or just show them if we want. So let's create a new file in the root called pullfaces.py. All right, so in order to do this, we need to implement the pillow library, which is an imaging library. So we're going to say from pill import image. Okay, and we also want to bring in, face recognition. All right, so just like we did, I'm just going to copy from find faces, these lines right here, and paste that in, and I'm going to get team 1. All right, so we have our face locations. Now I want to loop through the face locations. So I'm going to use a for loop, and I'm going to say for, we'll say for face location in face locations. And we're going to take the top, right, bottom, and left positions from face location. All right, then we want to set a face image variable, and we can get this with image, and then inside brackets we want to do top colon bottom, and we want to do left comma left colon right. So this will give us a face image in the form of an array that we can actually get the actual image using the pillow library. So let's say pill_image and set that to the image, okay, this that we brought in up here, and this has a method called from array, and then we want to pass in here face image. All right, and then we can show the image if we want by just doing .show. So let's save that, and we'll go ahead and run Python and pull faces.py, and it's going to use whatever you have as your default image viewer to show each of those faces, as you can see. All right, so it pulled it right out of that image. Now if you want to save these, because these are just being shown, we didn't save them, then you can actually do pill_image.save, but you have to put a file name. So remember, this is a loop, so this is happening for each instance or each face in the image. So for the file name, I'm going to put in an F string here, and I'm just going to use the top value. Okay, you could use whatever you want if you want to generate a random number or something like that, and do .jpeg. So now I'll go ahead and save that and run this again. Let's actually not even run the show. Let's go ahead and run this pull faces. And now over on the side, you'll see we have 38.jpg, 39, 72.jpg, and 101. So we now have these images of the people in the picture. Okay, so you can pull that out. If I ran this on team 2, it would save 11 images because there's 11 faces in the image. So just something cool that you can do. I'm going to go ahead and delete these though, these faces. Now the last thing I want to do is I want to be able to identify faces and draw a box around them with their names in an image. So I want to take this image right here of Bill Gates and Steve Jobs, and I want to be able to have a box around their faces with their names. And if there's other people in the image, it will just say unknown or whatever. And of course, you could change out the faces to whatever image you want. So, and it's just like, you know, on Facebook when you have an image and it recognizes your friends and it puts a box around their face with their name and so on. So let's create a new file here called identify.py. And this file is going to be quite a bit longer than the other ones that we've created and quite a bit more complicated. So let's go ahead and import face recognition, and let's say from pill we want to import image like we did before. We also want image draw because we need to draw on top of an image. And then I'm going to grab from face match these two lines here that gets the face encoding of Bill Gates. based on this image, the known billgates.jpg. And then I also want the Steve Jobs, so I'm going to change this to Steve, image of Steve, change this to Steve Jobs. And you could easily just change the person by changing the image. And we'll change that to Steve face encoding and change this to image of Steve. All right, so now we get the face encodings for both people. And the next thing we want to do is create an array of encodings and names. Okay, and of course you could do more than 2 people if you wanted to. So you could do this with your friends or whatever, a group of your friends. So let's say known face encodings, and we're going to set that to an array with Bill face encoding and Steve face encoding. Okay, then we want an array of known face names because we want to be able to put their names as well. So it's just going to be a string of Bill Gates and Steve Jobs. All right, so we have our encodings and name arrays. Now we need to load the test image. So load test image to find faces in. So I'll call this test image. You can call it whatever you want, but whoops, test image. And we're going to set this to face underscore recognition. We want to load the file, so load image file, and let's pass in the image we want to test, which is going to be img/groups/bill-steve.jpg. Okay, now we need to find all the faces that are in this test image. So let's put a comment here and say find faces in test image. So we need to basically get the face encodings. So we do that by first getting the face locations by using face recognition dot face locations and pass in the test image. Okay, then we're going to, I'm just going to copy this down, and we want to change this to face encodings, and we can get that with face recognition dot face encodings, and we want to pass in the test image, but we also want to pass in the face locations. All right, so that will get us the face encodings for this image here. Now we need to convert this to pillow format so that we can draw on it. So let's say convert to pill format. And we do that by setting a variable. We'll say pill image is equal to image dot from array, just like we did in the other file. And we'll pass in test image. Okay, so next thing we want to do is create a draw or an image draw instance so that we can draw on top of the image. So we'll say draw equals image draw, which we brought in from pillow, if I can spell. So image draw dot draw, and then we just pass in our pill image. Okay, so now is the difficult part. We have to loop through the faces that are on the test image, which is the one of Bill and Steve in this case. So let's say loop through faces in test image. So we're going to say for. Now we can pass in the positions top, right, bottom, left, and then we want to put right here, we'll use face encoding. So for each iteration we'll have access to this face encoding and the positions from it. And we would just want to do in, and then inside of this zip method we want to put the face locations and face encodings. All right, so we're going to loop through, and we have access to the positions for each iteration. Now we're going to set a value here of matches and set that to face recognition, and then remember that compare faces method. We're going to use that. We're going to pass in our known face encodings as well as the current face encoding. All right, and then we're going to just set name to, by default, we're just going to set it to unknown person. because if there's no match, that's what we want the name to be. But now we'll test for a match. So we'll say if match by just saying if true in matches. Okay, so if there is a match, so if Steve or Bill is in this photo, then we first want to get the index, so first match index, and we'll set that to matches.index where it's true. And remember, we have that known face names array. We're going to set the name value to known face names with the index of first match index. Okay, so it's going to look at this right here and get the first match. Okay, it's going to set that name. Now we want to go outside of the if statement. Make sure you go back. Don't stay in the if statement. And we're going to now start to draw. So we want to draw the box. Basically, we want to draw three things: a box around the face, and then underneath the box a rectangle, black rectangle or whatever color you want, and then the text inside of it. So this first rectangle we're going to draw is the box around the whole face. So let's say draw dot rectangle, and this is a little confusing. We're going to put two parentheses inside here, and then we want to do left and top, because remember we have access to these top, right, left to each image or each encoding. So we want to do that, and then the second parameter here is going to be another set of parentheses with right and bottom. All right, and then after the two parentheses, we want to put another parameter of an outline, and that's going to be an RGB color. So I'm going to do black 000. So that will draw the main box. Now we want to draw the label, which is a rectangle and the text. So we need to get the text width, text height, and we're going to set that to draw dot text size of the name. All right, and then let's go ahead and draw the rectangle first that the label is going to go on top of. And we want to pass in here another two sets of parentheses, just like we did before, and we're going to do left bottom, but we want to take away the text height. Okay, we need to position this correctly, and then take away 10. And you can experiment with this after you generate the image if it doesn't look right. And then we're going to put a comma right here, another set of parentheses with right bottom, and then after the two parentheses, put the fill in, which is going to be black, and the outline, which is also going to be black. All right, and that should do it for the rectangle. Now we want to draw the text, so draw dot text, and we're going to pass in here a set of parentheses with left +6, because we don't want it right on the edge, and then bottom, take away the text height, and then take away 5. All right, then we're going to put a comma here, that the actual text that we want, which is name, and then the fill of the text, which is going to be white. So I'm going to do 255 4 times. All right, now we want to go outside of the loop, so we want to go back to the first line here, outside of this for loop, and we're supposed to delete the draw instance from memory. That's recommended by the docs. And then finally we can display the image with pill image dot show. All right, so let's save that, and let's run Python identify.py. See what we get. And there we go. Wow, I'm surprised that actually worked on the first try. So we get this. This is the main box, the first rectangle we drew, and then the second rectangle right here with the label or the text inside of it with the name. So we get Bill Gates and Steve Jobs. Now I also have inside groups, I have a picture of Bill Gates, Steve Jobs, and Elon Musk. So I'm going to run the same thing but on that test image. So let's go and change right here, Bill-Steve to Bill-Steve-Elon. And we'll go ahead and save that, and let's run Python identify. and you can see we get Bill Gates, unknown person, and Steve Jobs. Okay, we get unknown person because we don't have Elon Musk as one of our encodings, one of our images or faces. And another thing we could do is save it if we want. So we could go down here and say save image, pill image dot save, and we'll call it identify.jpg. So now if we go ahead and run that, it will show it, and over here you can see it saved it as well with the boxes with the names. All right, so that's it, guys. Hopefully you enjoyed this, and take what you've learned and try to build onto it. Try to maybe integrate it into a web page. That's something I'm going to look into as well, is, you know, maybe uploading a photo and having it recognize people, and then show the image in the browser with the boxes around them or something like that. So there's a lot you can do. You can also do stuff with webcams. So check out the documentation and experiment a little bit. But that's it. Hopefully you guys liked this little tutorial. If you did, please leave a like, and I'll see you next time.